Welcome back. All right, so we have looping constructs. We have the ability to execute the same lines of code over and over again and evaluating them until some conditional evaluates to true. Now, there's a couple of things I want to point out about conditional operators. And this one is particularly important because it's one that is very, very easy to create problems for you without noticing it. So let me just walk you through this little bit of code, and then I want to get down to this little bottom piece right here. So remember that from the math library, which should be built into your Jupyter Notebook build or your Python build, we can import various things like sine, cosine, tan, log, and things like pi. So pi, of course, being 3.14, etc. So if I import from math both pi, the numeric value, and the function sine, I can do things like please print for me sine pi, and it'll print 3.14159, etc., etc. And of course, pi has an infinite number of values after that decimal point, and so this is just an approximation to pi, and that's really important for the following reason. If I print the sine of pi, so you remember what sine looks like, it starts at the origin, loops up, comes back down to here at pi at 180 degrees, and then comes back up to here at 360 degrees, or 0, pi, 2 pi in radians. So sine of 0 should be 0. But when I ask to print the sine of 0, what do I get? I get 1.22, look at that, e minus 16. This is scientific notation. This means it's 1.2, etc., times 10 to the minus 16. So imagine taking that decimal point right there and moving it 16 decimals over to the left. So it's close to 0, but not 0. So if I ask, is sine of pi equal to 0, there's the equality operator, the double equal sign, Python will say, no, it's not. Sine of pi is 10 to the minus 16. So when you are doing conditional operators, particularly the equality operator, you have to be exceedingly cautious when you're dealing with floating point numbers. And because floating point numbers will have an inherent amount of imprecision because of the nature of representing infinite numbers in a finite computer. And so here you have to be very careful. If you want to test if something is close to 0, you have to ask something like, is the absolute value of sine of pi less than or equal to 10 to the minus 15? In which case, for all you care about, that is 0. So this is just a cautionary tale that when you use the equality operator against floating point values, you are almost certainly in for a world of hurt because you will not have exact identities of, for example, things equal to 0. Okay. Now, we've seen really simple conditional operators. Is 5 less than x? Is a equal to b? Etc., etc. So we remember that we had the less than, the greater than, less than or equal to, greater than or equal to, not equal to, and the equality operator. And of course, you can combine things. And you can combine things with the logical operators that I'm sure you're all familiar with. So I can ask, is a Boolean expression A and a Boolean expression B true? And it's true if A is true and B is true, and it's false otherwise. So the logical AND of two things is true when they are both true and false otherwise. So it's sort of the normal reading of AND. I can ask, is this true or this true? And that whole expression, that whole logical combination of A and B will be true if A is true or B is true. So is it sunny outside or is it warm outside? So if it's sunny outside but cold, it's true. If it is cloudy outside but it's warm, it's true. Okay? Whereas if I say, is it sunny outside and is it warm, both of those have to be true for me to say it is sunny and it is warm. Okay? And then the last operator, the logical operator, is not. So if I say it simply is just inverting. So if A is true, then not A is false. And if A is false, then not A is true. By the way, in lecture 10 and 11, we're going to come back to logical AND, logical OR, and logical NOT. And amazingly, what we are going to see is that these three logical operators form the building blocks of a modern computer. That this is how all computation is performed, is simply with logical AND, logical OR, and logical NOT. So this is going to revisit us at the end of this semester. For now, we care about it in the use of logical operations for conditions and things like while loops, and very shortly inside of conditionals of if statements, which we'll see in a little bit. So let's just do a couple of examples to make sure we understand. So this is just an expression. It is now a series of logical operators. I have two simple Boolean expressions here. I'm ANDing the result, and then I'm NOTing the whole thing. So read this the way you would read any normal arithmetic operation from the inside out. So we're going to evaluate these two, we're going to AND them, and then we're going to NOT them. So is 3 less than 4? Sure, that's true. Is 10 less than 12? Sure, that's true. If this is true and this is true, then the AND is going to evaluate to true. So everything is going to boil down to a single true, and then I'm going to NOT the true, which is that, and so the whole thing will be a false, of course. All right, let's do another example. Is 10 greater than 12? False. Does 5 not equal 6? True. Is one of these true? Yes. This one right here, and I don't care if that's false, so the whole thing evaluates to true. Here's a ridiculous looking statement, but I'm going to do it anyway. You can compare equality not just of numbers, strings I'll show you in a minute, or floating point numbers, being careful with floating point numbers, particularly around equality, but Booleans is just another type. So I can ask, does false equal false? Sure. So false equal false? True. If I NOT that, what do I get? False. If I NOT that, what do I get? True. Okay. So that's a little bit of a silly example, but I just want to have you be able to work these expressions out from the inside out. You can do some sort of funny things. In Python, true is greater than false. I think this is a little philosophical, saying that the truth is better than the falsehood. Sort of cool. But you can actually assign these values. One way to think about this is true is sort of like a 1 and false is like a 0. You can do alphanumeric ordering. So an aardvark is less than a zebra because alphabetically it shows up, A is before the Z. And there's lots of funny things you can do, but you can't compare aardvarks in numbers. This is as silly as it gets in Python. All right. There's one really cool thing about these logical operators that I really like, and it's called short-circuiting. And it turns out it's both a feature and can be very useful to you when you're doing certain things. So let's look at this expression here. I'm going to assign the variable x to be 0. And I'm going to ask you to please evaluate this Boolean expression that is the AND of two Boolean expressions. So let's just go ahead and look at the Boolean expressions. I'm asking, is x not equal to 0? Okay, good. So that will evaluate to true or false. So if x is 0, that'll evaluate to false. And if it's not 0, it'll evaluate to true. Good. Here I'm asking, is 3 divided by x less than 4? So here I have to evaluate this expression. But to evaluate that expression, I have to evaluate this numeric expression first. So I'm going to divide 3 by x, and then I'm going to compare that value to 4, and I'm going to return true or false. Now, when x is 0, what's going to happen right here? I'm going to try to divide by 0, and I'm in a lot of trouble. Yep. So that's going to be a little bit of a problem for me. But you can go ahead and type this into Python, and this will not give you an error. It will not give you a divide by error. It will return false. And the reason is that the way these AND statements are read or interpreted by Python is it starts from left to right. So what's going to happen, it's going to evaluate this. Is x not equal to 0? No, it's 0. So this evaluates to false. And Python's pretty smart. It says, look, if this is false, I don't care what this is. Why do I not care? Because it's an AND. And once one of these statements is false, the whole thing is false. There can be 20 other statements here and they can all be true, but it is absolutely irrelevant to me. So this is called short-circuiting. If you're evaluating a series of ANDs and the first one evaluates to false or any of them evaluates, you stop evaluating. You short-circuit the computation and you end. A couple of interesting things about this. In this case, this is sort of cool. We can test for division by 0 by putting it inside of a conditional and not having to worry about embedding things. It's also really efficient. If I've got 10 different ANDs and the first one evaluates to false, what am I doing all these computations if I know what the answer is already after the first expression? So this is a way of getting a little bit of computational efficiency, but also be careful because sometimes you may want this thing to get evaluated and it won't if in fact this thing evaluates to false inside of an AND statement. All right, let's do a drill. I'm going to show you a little video and I'm going to ask you to write code that generates that video. And to do that, of course, you're going to need a while loop. Okay, so let's go ahead and watch the video, and then I'm going to show you my solution. So you can pause it right after the video and just write a little bit of code to do that. Okay, so you probably remembered that we did an animation, and this was the scaffolding for it. So we're of course going to import draw SVG. We have something that draws the frame. That's of course the hard work of drawing the frame on every animation. And then we have the while loop. And let me just remind you what the while loop the animation loop here. So with draw.animate Jupiter, that's the animations function that's given to us by draw. Draw frame is that function right there. There is the delay. How much do I pause between every image as anim? And then anim is being used to call draw frame so it knows that it's part of the loop. Okay, so this is the scaffolding that you saw earlier on. And now let's start filling in the details. So what did I show you? I showed you an expanding circle. Yeah. So now you have to think a little bit, what does that mean? Well, all an animation is a series of drawings. So I'm going to draw a small circle, slightly bigger, slightly bigger, slightly bigger, slightly bigger, slightly bigger, and then I'm going to stop when I get to some limit at the end. All right, so as you're thinking about that, think about the constructs we have. I told you you're going to need a while loop. And so think about that. If all I'm doing is drawing circles of varying sizes, that's just calling a function that's going to draw a circle, and I have to simply specify how big the circle is and do that over and over again, changing the size of the circle. It's begging for a while loop. All right, so let's see what that looks like. Okay. Crap. I think I went down. No, it's okay. All right, so let's put it all together and see what that looks like. Here's my draw frame. I'll come back to that in a minute. And here is my looping animation, and here's my little while loop. Okay. So notice that I'm going to call. I'll go through all the details in a minute, but notice I'm going to call draw frame with R. R, of course, is going to be the radius of the circle. I'm initializing that to 0, and you can see that I'm incrementing it here. So let's go look at draw frame, and then we'll come back and look at the nature of this looping construct. So outside the animation, let's just look at this. So I'm passing in a parameter, a variable, a value, R. It's the radius of the circle. This thing, all it has to do is draw a circle. Okay, so that's easy. We know how to define a canvas. There it is right there. I made mine 250 by 250. You can do whatever you want. So D now is the canvas. I'm going to append to the canvas a circle centered at the origin, 0, 0, the center of the canvas, because I specified the center to be there. And mine is blue. And the radius is R right there. So that variable and that variable, of course, are the same thing. Good. So this thing, whatever R you tell it, it's going to simply draw a circle. This animation loop is going to do the job of drawing it and then erasing it and then drawing it and erasing it with the right delay. So now we've just got to do it over and over again with increasing radii in order to get the expanding circle. All right, so I've got a little r equal to 0. I've got a big R equal to 100. I'll come back to that in a minute. And now I'm saying, while little r, the radius of the circle I'm drawing, is less than big R, 100, that's the maximum radius that I want. I could have made that anything, of course. Please call draw frame, obviously through anim, because it's part of the animation loop, with R. Increment R by 1. I could have incremented by 2 or 3. It just depends on how fast you want to grow it. Loop back up. Now R is going to be 1. Draw a radius 1. Draw a radius 2, 3, 4, 5, 6, 7, up to 100, and then stop. So notice there it is right there, those two. This looks a lot like the other while loops, right? The print, the rotate, is I'm calling a function with a variable. That variable keeps changing until some condition holds true, and then I'm out. Okay. Good. So here's a little thought exercise. So we don't have all the coding constructs to do this. So I want you to think a little bit about this. I'm going to show you a video of now a pulsating circle, and I want us to just think through how we would do that, and then in a subsequent lecture we'll actually do it as a drill. But for now, look at the video and we'll come back in a second. Okay, what did you see there? You saw a circle going up to the big R, so that maximum, and then it went back down, and then up and down, and up and down. Okay, so I want to think through how we did this. So here's what we had before. I had my radius. So we had most of it, right? We had this, but then we have to sort of go back down until it collapses, and then go back up until it's full, and so on and so forth. So this would get us, sort of halfway there. It would start from a small circle and get to the very end. But now what do I want to do? I sort of want to start decrementing the radius until I get to sort of the bottom, right? So here's the thought exercise. So I could say, well, if r is equal to r, so I got to the big end, instead of incrementing, maybe I can decrement, right? R equals r minus 1. But that's a little bit of a problem because then on the next iteration, r is going to be, this little r, the radius is going to be smaller than the big thing, and I'm going to start incrementing. So I'm going to sort of do this very rapid thing. So that doesn't really work. I can't just, once I get to the end, I can't just start decrementing because then I don't know when to stop. So we sort of have to keep track of something. We need what's called a state variable. We need to know, is the circle expanding, in which case I should increment, or is it contracting, in which case I should decrement? And then we need to know, well, what does it mean to finish incrementing, expanding rather, and what does it mean to finish contracting? Well, this is what it means to finish expanding, and to finish contracting means that the radius has gone to 0. But now we've got to do that sort of within this while loop. And so we have two conditions now, and we need to control this. And so we need a little bit more machinery here. And that machinery is conditionals. We need to be able to say that we are going to evaluate certain code under certain conditions. And those conditions are the same conditions that we have in the while loop. They take on a different nature. The while loop says, keep evaluating this code over and over again until this is true. A conditional says, evaluate this if it's true, and if it's not, do something else. Okay? So when we come back, we're going to talk about conditional operators. They're going to be related, but not exactly the same as while loops because they rely on conditions, on Boolean conditions. And then we're going to actually do that drill with the expanding and contracting circle because then we will have the machinery to do it. All right, we'll pick it up in a few minutes. See you soon.